Perfect. Okay. Thanks for filling out that survey for me. It was really interesting to see some of the statistics of how you guys are feeling with the class, your level of understanding, that sort of thing. It was interesting to see that there were not a lot of people that said math was a little bit different, maybe, but with physical science, it felt like there were not a lot of people that were at that 5 level of understanding. There were a few, and that's understandable. I'm trying to figure out ways of helping you guys learn and understand this content a little bit differently. And so I appreciate the feedback and the honesty that you guys gave with even how much you're working with friends or all that sort of stuff. I really appreciate your honesty in that. But we are actually moving on to the next unit here. We are moving on to Unit 6 Quadratics. And so what we're going to look at is some of the basics of quadratics. We're going to look at vertex form tomorrow when we go through these notes and talk about how to graph in that manner. This particular unit has a couple more lessons, so we actually won't have an assignment for this week for for Unit 6, but for next week we will start with the quiz. As you've seen on your Google Classroom, you also do have, I'm posting it as a PDF as well. That was what I was just adjusting, but this linear inequalities exam is also present and up on your Google Classroom, so you can be working through that this week. The notes we will be doing, though, will be through these quadratics here. So starting this off here, a quadratic function is a function with the following characteristics. The graph is in the shape of a parabola, and that means that the graph can be in one of two shapes. It can either be in a shape that looks something like this, or it can be in a shape that looks something like that. And the other thing that must be present with a quadratic function is that it must have an x squared term when simplified. That can be any letter. It does not necessarily have to be x squared. It could be, for example, like an n squared. But the idea is that when we're graphing it, it appears as the x term instead of the y term, if that makes sense. So those are the qualities that make a quadratic function. Those are the things that absolutely must be present when graphing and looking at a parabola. So we are given 3 different little graphs here, and the question in example 1 we were asked is, which of the following represents quadratic equations? And we said that it needs to either look like a smiley face or a frowny face. It needs to look like one of those two. And the second that we said is it must have an x squared term when simplified, no higher powers. So looking at this first example, I'd look at this and say, well, there is an x cubed. Immediately, I would know that this is not a quadratic function. It does not have an x squared, and there's no way of me actually simplifying this expression either. The other thing that I would look at is I would look at the shape of this graph, and this I could very clearly see is not a parabola. And so, because this is not a parabola, and because we don't have an x squared term, we would say that this is not quadratic. Second example, it appears like this is a parabola. This is a parabolic shape. So parabola, check. But in our equation, we don't have any x squareds. I have an x times bracket x plus 4. And what I would do with this then is the key kind of phrase in this top sentence here is it has an x squared when simplified. This is not in simplest form. If I were to FOIL this out and put this x, multiply it by both of the components that are inside the bracket here, we would end up with x squared plus 4x. And when you do that, you see that we have, in fact, an x squared. So this is quadratic. Next one. Example C here. We have a straight line. That is not a parabola, so immediately I'm inclined to think that this is not quadratic. And then if we look up here at the top, we would see, well, I actually have an x squared. So in theory, this should be a parabola, right? There is an x squared. Again, this is not in simplest terms. If you were to actually do 0 times x squared, that's just 0. So we'd end up with 2x plus 3, which is in the same format as y is equal to mx plus b, which we said was the equation for a line. And so I know then that this is not quadratic. when we are talking about parabolas, they all have the following characteristics. So there are all of these ways that we can describe parabolas. First and foremost, they have the vertex. This is the highest or the lowest point. So that will either be this point down here or this point up here. It'll have one of those 2 points. It must. It'll have a minimum or maximum value, and that will be the y-coordinate of the vertex. So again, if we were to draw this out, that would be either this bottom point here. Let's see if it'll actually let me move this around freely. It won't. Okay. So that'll either be this bottom point here, where this would be the minimum, or it'll be this top point here where that would be the maximum. So we'll have one or the other. It'll have a direction of opening, so it depends on the sign or the coefficient of x squared. So if we have a positive x squared, that'll open up. If we have a negative x squared, that will open down. So that's where we get either the smiley face or the frowny face. The x-intercept, that will be the point where the graph crosses the x-axis. Here we can have either one x-intercept, two x-intercepts, or you can also have no x-intercepts. The way that would look is, let me just draw a parabola like this, and then let's see if I can select that there. Okay. So what that would mean basically is if I'm looking at this particular graph here that I have on the right, if I have one x-intercept, that means that it must intercept the x-axis right at the vertex, so right at that point. And actually the red graph that's there already does that. We could have 0 x-intercepts. If our parabola is floating up here like this, it doesn't ever cross this x-axis, and so there are 0 x-intercepts. The last alternative is that it crosses the x-intercept, or the x-axis, at 2 points. And that would be if our parabola curved below the x-axis and then curved up. Conversely, it could also be rotated. So we could flip vertical like this. It could be like this. It could be like this. Or it could be down here. And those would be our 3 cases for x-intercepts. The y-intercept is the point where the graph crosses the y-axis. And with this one, with the y-intercept, there is always 1. And the reason that there's always 1 is that this graph should actually have little arrows at the end of it, because parabolas will extend forever. They will go on forever and ever. And so even if I redraw this little parabola like this, even if it doesn't appear like it will cross the y-axis, this line here will extend forever to a point where it does eventually intercept at the y-axis. It might be at a very, very high point, but at some point it will have a y-intercept. The axis of symmetry is a vertical line that passes through the vertex. So the axis of symmetry would be this line here. And it's kind of like we're looking at a mirror. If you look at the left side, it is the opposite but identical to the right side. So both sides of these parabolas are exactly identical is what that means. So that's the axis of symmetry there. Domain is all of the possible x values. And in this case, it will always be x, e, r. And what that means is that x can be all real numbers. As we said, this graph will continue going right forever, and it will continue going left forever. All possible y values, well, whatever our minimum or maximum will be, will impact the possible y values. We're actually going to talk about each one of these points in terms of this graph on the right here, and so I think that's probably where we'll discuss that one a bit more. But if we are looking at the vertex of this graph, we would say that the vertex of this graph would be this point right here that I just drew in red. And that's at the point 0, comma, excuse me, that shouldn't be 0. This will be at the point -2 as our x value, comma, 0. -2, comma, 0. In terms of our minimum or maximum value, well, we said that the minimum or maximum would be wherever, oops, those are not very good lines. We said the minimum or maximum would be at this point right here. And so because our minimum is at 0 here, we would say that y will be greater than or equal to 0. And that would be our minimum. And actually, I don't want to put greater than or equal to. Y would be equal to 0, just because we're only describing the minimum. So that's our minimum or maximum value. Direction of opening, when you're writing that, you just have to say up or down. This one opens up because it's our happy face. The x-intercept, this particular graph only has one x-intercept, and it's right at the vertex. So we know that our x-intercept is at -2, comma, 0. The y-intercept, we said that there's always one of these. Our y-intercept is this point right here, which is at 0, comma, 8. Axis of symmetry, we said that that will always be the vertical line that passes through the vertex. And because we want it to represent a vertical line, it will always be x is equal to something. And in this case, the vertex occurs at the x value of -2, so our axis of symmetry will occur at x is equal to -2. The domain, as we said, is always XER. And the range, the last part that we need to answer here, is we need to describe all of the y values that this could be. And so this, we said that the minimum value of y was x must be greater than or equal to 0. The other thing that we say is that y can be all real numbers greater than or equal to 0. So y can be any number traveling upwards. It could be infinity, it could be 0.0001. As long as it's bigger than 0, the requirements of this parabola are met. Does anyone have any questions so far? Okay, awesome. Oops. Why are you doing that? Okay. So what we want to do now is we're going to fill in the table for each of these graphs. So what I would like everyone to do is I would like everyone that has a mic, which I know a few of you do not, can you unmute yourselves and we'll do and walk through these questions together. Awesome. Okay. So I'm going to bug Boston first. Boston, I would like you to tell me, for example 2 here, what is the vertex of this graph? What point is it at? Awesome. 2, 4. Ethan, what would the maximum value of this graph be? Awesome. Okay. Direction of opening, Heidi. That's the easiest one in the world. Yeah, very well done. Super proud of you. Who's next? Mackenzie, can you tell me the x-intercepts of this particular graph? Awesome. And so how we wrote the x-intercepts above was we wrote them as a point. So awesome, yeah, I'll write that at 0, 0 is one of my x-intercepts, and the other one occurs at 4, 0. Tegan, what is our y-intercept? It is 0, 0. Right at the origin. Axis of symmetry, we are back up to Boston. X equals 2, lovely. And so because it's x is equal to something, that means that we will have a vertical line just like that. Perfect. Domain, Ethan. What did we say the domain was always in the case of parabolas? Pass. Heidi? Awesome. Yeah, exactly. It can always be all real numbers because this graph will extend forever. Ethan, we're back to you then. What is the range? That's one of the components of the range for sure. Can y be... Nice. Less than or equal to... Oh, not 0. That should say 4 there. Less than or equal to 4. Lovely. Nice work, everyone. So we're going to do 2 more of these. So let's do this next one here. Okay. The vertex of this particular graph. What I'm going to actually do, just to help you out a little bit, is show you that this is 1. This would be 1.5. This would be 2. This would be 2.5. So we could fill in then the and then obviously this one's 2, -2 as well. So we just finished with Ethan. Mackenzie, what is the vertex of this graph? I'll do this as well just to help. -1, and this is 1 here. Yep. Yeah, so that would be -2.25. Yeah, exactly. -2.25. Yeah, -2.25 is the exact same as that number there. So if that is true for the vertex, Tegan, what is the maximum or minimum of this graph? Awesome. Yeah, so as you've kind of noticed, you can borrow the vertex for the max or min. Whatever the y value is, that will be the maximum or the minimum. Direction of opening, that's too easy. I'm going to put up. Sorry, Boston. I'm not giving that one to you. X-intercepts, Boston. How many do we have and what are they? -2, 0, and 1, 0. Very nice. Y-intercept goes to Ethan. Lovely. Axis of symmetry goes to Heidi. So that's the line that cuts. Yeah, exactly. Exactly. -0.5. So what you can notice then is that the maximum or minimum is directly related to the vertex, as is the axis of symmetry. Both of those two, you're just stealing the information that you filled in with the vertex. So obviously what we're starting to notice is that the vertex is the most valuable component of parabolas. And as we do lesson 2 tomorrow, we'll see more of that. Mackenzie, what is the domain of this graph? Very nicely done. And Tegan, the range? Perfect. Well done, everyone. And we will finish with this last graph here. So it's worth noting too that all of the equations are up at the top here. And so we could plug in these values. What's interesting to note about these equations is that instead of them saying y is equal to something, this says f of x. And what this means is that this is a function of x. And the same way of describing that, you can also describe that as it being y. So basically, this y component is determined based on whatever x is. That's basically what f of x is equal to. For those interested in taking calculus, you don't ever deal with y. You only deal with f of x's or f of g's. And the reason for that is you want to be able to deal with one term when you're solving for these problems. So basically, whatever answer we arrive at is totally dependent and totally stringent upon whatever x is. That's what f of x is saying. Okay, last one here. Again, I'll help you out with this. This is 1 here, 2, 3, 0, -1 is over here. So we finished with Tegan, so it goes to Boston. What is the vertex, Boston? Yeah, 1, -3. Nice. Ethan, do we have a maximum or minimum, and what is our maximum or minimum? Beautiful. We can actually do the axis of symmetry right away, so why don't we do that? Because we have the vertex, we would know that that would be x is equal to 1. So again, I know that based on the fact that I just know the vertex. I can fill in those two pieces of information solely based on what Boston gave us. Direction of opening is obviously up in this case. Heidi, what is our x-intercept or our intercepts? Nice. I'm going to call that 2.25 because 2.5 would be right here. That's okay. It's a little bit tough online to see those sometimes. That was Heidi. We go to Mac. What is our y-intercept? Awesome. So 0, -1. Tegan, domain. Beautiful. And Boston, you get to finish off with the range of this. Greater than. Awesome. Okay. So that is basically just kind of us segueing into dealing more with quadratics. Those that were helping out, thank you. I very much appreciate that. I like hearing your voices. Seems like you guys have a pretty good handle on this stuff. I'll post this video as well. Let's actually stop the recording here.